Hello my dear students, welcome to my YouTube channel. So today we are going to solve 20 best math MCQ problems for CBSE 2025 examination, and this is part number 5, and the links of the previous parts will be in the description box of this video. So let's start without further any ado. Question number 1: if A and B are symmetric matrices of the same order, then A B transpose minus B A transpose is a skew symmetric matrix, null matrix, symmetric matrix, or none of these. So let us take this matrix A B transpose minus B A transpose. So we have already given that A and B are two symmetric matrices. That means A transpose is equal to A and B transpose is equal to B. This is given. Okay, now we are transposing this whole matrix A into B transpose minus B into A transpose whole transpose. So according to the transpose law, A B transpose this whole transpose minus B A transpose whole transpose. So according to this, B transpose and its transpose into A transpose minus A transpose again transpose into B transpose, because we know that A B transpose whole transpose is equal to B transpose into A transpose. Okay, so this is B transpose again transpose, so B transpose again transpose is B, and this is A transpose minus A B transpose. That means this is equal to minus of A B transpose minus B A transpose. That means this matrix, if we transpose this matrix, we are getting minus of this matrix again. So that implies that A B transpose minus B A transpose is a skew symmetric matrix. Skew symmetric matrix. Okay, A option is correct. Next problem. Question number 2. If the points this and this are collinear, then x1 y2 is equal to what? Okay, so these 3 points taking this A B and C, so A B C are collinear. Okay, so we will find the AB straight line, and then we will satisfy C in the equation of AB. So equation of AB, this is equal to y minus y1 divided by y2 minus y1 divided by x2 minus x1 into x minus x1. Now this is the equation of AB, and we will put the C point in this equation and it will satisfy, because these three are collinear. So almost here will be C, or here maybe C is there. So now put this is x and this is y. So in place of y, this is y1 plus y2 minus y1. Here y2 minus y1 divided by x2 minus x1, and here x2 plus x1 minus x1. So x1 cancelled, y1 cancelled, and this is equal to x2 minus x1 into y1 y2 y2, this is equal to x2 into y2 minus y1. So this implies that x2 y2 minus x1 y2, and here x2 y2 minus x2 y1. So x2 y2 cancelled. This is x1 y2 equal to x2 y1. So here it is given that x1 y2, this is equal to x2 y1. That means option number A again correct, x2 y1. Next problem, question number 3. If A and B are non-singular matrices of same order with determinant of A equal to 5, then determinant of B inverse A B square is equal to what? Okay, so A and B are non-singular. Non-singular means matrices. Non-singular means date of A not equal to 0. So that is also not equal to date of B. So you know that date of B inverse A B square. B, this is square. So date of B inverse A B, this is equal to date of A. Okay. So this is date of A square. That means this is 5 square. So this is 25, and this is B option is correct. Okay. Next problem. The value of n such that the differential equation this where xy belongs to R plus is homogeneous is. So what is the value of this n? So this is the equation x to the power n dy dx equal to y log y minus log x plus 1. Okay. So dividing by x to the power n, this is dy dx. This is equal to y by x to the power n, and this is log x, log y minus log x. So this is log y by x plus 1 with the property of log. Okay. So see that if x to the power n equal to x, that means n equal to 1. So that means this equation will be y by x, and this is log y by x plus 1. So if we replace y by ky and x by kx, this equation will not change. Okay, that is why this is homogeneous equation. Homogeneous equation. If we change y with ky and x with kx, then if the equation did not change or did not alter, then it is called homogeneous equation. So what is the value of n? This is n equal to 1, and option number B is correct. Next problem. Question number 5. If A equal to this matrix is a skew symmetric matrix, then the value of A plus B plus C is what? So A is a skew symmetric matrix. That means A transpose equal to minus A. And you know that the diagonal elements of a skew symmetric matrix is always 0. So that means straightforward, this is A equal to 0. And these symmetric elements are negative of each other. So minus B is equal to minus 3. That means B equal to 3. And C is equal to minus 2. Because here it is 2. That means here should be minus 2. That means C should be minus 2. That means C is minus 2. So A plus B plus C is equal to 0 plus 3 minus 2, that is 1. So option number A is correct. Next problem. Question number 6. the interval in which the function f defined by e to the power x square is strictly increasing is. So the function is fx equal to e to the power x square. Okay, so we are taking first derivative f dash x equal to e to the power x square into 2x. The derivative of x square is 2x. So this is equal to 2x into e to the power x square. Okay, so the interval where e to the power x square is strictly increasing. So for the function fx increasing, we need f dash x is greater than 0. Okay, so e to the power x square is always greater than 0. We have no problem with it. So that means 2x should be greater than 0, and that is x should be greater than 0. So the interval is 0 to infinity. Okay, now it is in the option number D. So D is correct. Okay, I hope you understand. Next problem. Problem number 7. The feasible region of the LPP is shown in the figure. Okay, z equal to 2x plus 5y be the objective function. Okay, maximum z occurs at which point? Okay, so z equal to what? 2x plus 5y, and the corner points is this 0, 0, 6, 4, 5, 3, 6, 3 and 7, 0. So z at 0, 6, this is equal to 30. Z at 4, 5, this is equal to 4 to the 8, 5 5 the 25, 25 8 33. Z 6, 3, 12 plus 15 27. Z 7, 0, this is 14. So you can easily check that the maximum occurs at this point. This is 33. So at 4, 5. Okay, so D option is correct. 4, 5. Z maximum of Z occurs at 4, 5. Okay, next problem. Question number 8. The function f, that is from R to Z, is defined by f of x equal to box x, where box x denotes the greatest integer function. Then it is continuous at x equal to 2.5 but not differentiable at 2.5, not continuous at 2.5 but differentiable at 2.5, not continuous at 2.5 but not differentiable at 2.5, and continuous as well as differentiable at 2.5. So continuous at but not differentiable, this can happen. Not continuous but differentiable, this cannot happen, because if this is differentiable at 2.5, then it has to be continuous. There was a theorem that if differentiable, that should implies continuous, but not vice versa. So this option is incorrect. Now we have to check A, B, C, D, A, C, D. So the function fx equal to box x. Now the graph of this function is like this, looks like this. This is from 0, this is 0, this is 1, this is 2 and this is 3. So from 0 to 1, this is 0, and in 1, this is 1, this is 1, this is 2, this is 3. Okay, from 1 to 2, this is 1, and 2 to 3, this is 2, 3 to 4, this is 3. Like this is like step function. This is first step, and here this is 1, this is this is blank, this is blank. It jumps at the integer points. So here it is 2.5. Here you can easily see that here the function is continuous and differentiable. Okay, so which option is correct? D option is correct, continuous as well as differentiable at 2.5. You can check using the definition like this: x tends to 0, 2.5, fx equal to, this is plus, and limit x tends to 2.5 minus fx, and this is f of 2.5, all are equal to 2. Okay, so this is continuous. And what is differentiable? So this is, the differentiation is 0. You can easily check that it is the parallel of x-axis. So f dash x equal to 0. Okay, so this is also differentiable. That is what we need. Okay, so next problem, question number 9. If cos inverse x is greater than sin inverse x, then x lies between what? So we know that the range of cos inverse x lies between 0 to pi, and the range of sin inverse x, this is between minus pi by 2 to pi by 2. Okay, so the intersection region is 0 to pi by 2. So in this region, sin inverse x is less than cos inverse x, because cos inverse 0 is equal to 1, which is greater than sin inverse 0, which is 0. And in this range 0 to pi by 2, cos inverse x is decreasing function and sin inverse x is increasing function, because the derivative of cos inverse x is minus 1 by root over 1 minus x square, and the derivative of this is root over 1 minus x square. So this is less than 0 and this is greater than 0 from 0 to pi by 2, uh, because the value is always 0 to 1. Okay, so that's why this is greater than 0 and this is negative. So that means cos inverse x is decreasing and sin inverse x is increasing, and ultimately sin inverse x is less than cos inverse x. So the answer will be option number D, that is x greater than 0. Okay, so next problem, question number 10. For the linear programming problem LPP, the objective function z is equal to 4x plus 3y and the feasible region determined by a set of constant is shown in the graph. Okay, this is the graph and this is the feasible region. Which of the following statement is true? Maximum value of z is at r 40, 0. Maximum value of z is at q 30, 20. Maximum value of z at r 40, 0 is less than value of 0, 40. Then the value of z at 30, 0 is less than value of 40, 0. So let us compute. So z at r, which is 40, 0, 40, 40, 0. So for zr, this is 160, because 4x plus 3y, this is 4x plus 3y. So 4 into, okay, 4 into 40, that is 160. And z of q, this is q 30, 20. So this is 30 means 120 plus 60, 180. Okay, z of p, z of p, what is p point? 0, 40, this is 120. Okay, any other information? So this, so maximum of z is at 40, 0. This is not correct, because this is 160 and z of q is 180. Okay, option number B, Maximum value of z at q 30 comma 20, this is correct. Option number C, value of z at r is less than value at p. This is not correct. Value of z at q is less than value at z equal to r, because q is highest, so it cannot be less than anything, so that is D also incorrect. So B option is correct. Maximum occurs at 30 comma 20, that is point q. Next problem. Question number 11. If f and g are continuous functions in close interval 0 comma a, satisfying fx equal to f of a minus x and g of x plus g of a minus x equal to a, then integration 0 to a fx into gx dx is equal to what? So the integral is 0 to a integration fx into gx dx. Recall that there was a property of definite integral, that integration 0 to a fx into dx, this is equal to 0 to a f of a minus x dx. Okay, so according to this property, this is equal to 0 to a f of a minus x into g of a minus x dx. Now replace g of a minus x and f of a minus x. So f of a minus x is equal to f of x. So this is 0 to a, this is f of x, and g of a minus x, what is g of a minus x? This is g of a minus x, this is equal to a minus g of x. So this is a minus g of x into dx. So this is equal to 0 to a into fx dx minus 0 to a, sorry, 0, this is 0 to a, 0 to a fx into gx dx. Again this is same thing, this is, so 2 into 0 to a fx into gx equal to 0 to a is outside the integral, a fx dx. So that means from here we are getting 0 to a fx gx into dx, this is equal to a by 2 integration 0 to a fx dx. Okay, so that means option number C is correct, a by 2 0 to a fx dx. Okay, next problem. Problem number 12, integration 0 to 2 pi cosec to the power 7x dx. So again we will use 0 to a fx dx is equal to 0 to a f of a minus x dx. So this is, let us, this is integral is I equal to 0 to 2 pi cosec to the power 7x dx. So that means this is equal to 0 to 2 pi cosec to the power 7 2 pi minus x dx. So the value of cosec to the power 7 into 2 pi minus x. So this is 2 pi and minus x, it is in the fourth quadrant, and in the fourth quadrant cos is positive, that means I equal to 0 to 2 pi minus cosec x whole to the power 7 and into dx, and this is equal to minus 0 to 2 pi cosec to the power 7x dx. So this is I equal to minus I, and this is 2I equal to 0. So that means I equal to 0. So the integral is equal to 0. A option is correct. Next problem. Question number 13. If mod A equal to 3, mod B equal to 4 and A plus B equal to 5, then what is A minus B? You can observe that This is 3, 4 and 5. These are Pythagorean triplets. Pythagorean triplets. So this is A, this is B, and this is C. So take this is A, this is B. So this is A, this is B, and this is C. So this is A equal to 3. Oh, sorry. This is A, this is B, this is 4, this is 3, and this is 5. So this is A plus B, A plus B vector. So what is A minus B vector? A minus B vector. So from this A plus B, mod of A plus B, we can easily find out the angle between A and B is 90 degree, because A plus B, this mod is equal to root over mod A whole square plus mod B whole square plus 2A mod B cos theta. So this is equal to 5, and this is equal to 3 square plus 4A square, and this should be 0, because that will, if this is not 0, then this will not be 5. So from this 2AB, also you can check cos theta equal to 0. So cos theta equal to 0, that means theta equal to 90 degree or pi by 2. That means these two vector are perpendicular to each other. So what is A minus B dot A minus B? Okay, this is equal to mod A whole square plus mod B whole square minus 2A dot B, and this is also equal to mod A minus B whole square. So this is equal to mod A whole square, this is 9 and this is 16. Okay, A dot B is equal to 0 because A and B are perpendicular. So this theta is 90 degree between them. So this is minus 0. Okay, minus 0. So that means A minus B is also equal to root 25. That is to 5. Okay, sorry, 5. So also A minus B equal to 5. That means option number C is correct. Next problem. Question number 14. The value of A if the angle between P vector and Q vector, this is obtuse, is. So what is P vector? P vector is 2A square I cap minus 3A j cap plus k cap. And what is Q vector? Q vector is I cap plus j cap plus A into k cap. So what is P dot Q? This is equal to 2A square minus 3A plus A. Okay, T 3A plus A. Okay, so this is equal to 2A square minus 2A. Okay, A common, 2A minus 1. Okay, 2A common, so A minus 1. Okay, rewrite it. 2A common, A minus 1. A minus 1. Okay, what is P dot A? P dot A is mod P into mod Q into cos theta. This is equal to 2A into A minus 1. What is mod P? Mod P is, I am writing here, mod P is equal to, okay, root over 2A square whole square plus 3A square plus 1 square, and mod Q is equal to root over 1 square plus 1 square plus A square. Okay, this is equal to root over 4A square, square 4A to the power 4 plus 9 9 9 9 9 a square plus 1 and into q square is 2 plus a square. Okay, then cos theta equal to 2a into a minus 1. Now this is cos theta equal to 2a into a minus 1 divided by this term and this term. So we have to find theta is obtuse. That means theta is greater than 90 degree and less than 180 degree. That means theta is in the second quadrant. And here cos theta is negative. That means this should be negative. So to make it negative, this 2a into a minus 1, this should be negative. Okay. So that means a minus 1 should be negative and a is less than 1. Okay. At a equal to 1, this is equal to 0. Okay. And at a equal to 0, this is also equal to 0. That means the interval should be 0 comma 1, because at 0 this a should give 0 and at 1 this should give 0, and a between 0 to 1 this should be negative. So option number B is correct. 0 to 1 open. Next problem. Question number 15. What is the general solution of the differential equation this? So this differential equation has a solution from these four. So if we differentiate these equations, we should get this differential equation. So let us derivative first function. So this is dy dx equal to u into v rule x divided by x plus log x. First derivative of log x, x is fixed, so x divided by x, and then derivative of x and log x is fixed, and derivative of c is 0, so this is plus 0. So this is plus 0, so that is equal to 1 plus log x. Okay, so you can see if this is dy by dx equal to log x, then we can write it as e to the power dy dx or y dash, this is equal to x, because log x is equal to dy dx. Then this one should be cancelled out and this is should be minus 1. So here if it is minus x, then this will give us minus 1, and from this we are getting 1 plus log x. Okay, so 1 cancelled. This is y dash equal to log x, and y dash equal to log x will give us y dash equal to log x will give us y dash equal to e to the power y dash equal to x. So this is e to the power y dash equal to x. I think this is the mistake of the question. This should be e to the power y dash equal to x, and for this equation this is 1 plus log x plus 1, so that means this is 2 plus log x, this is equal to y dash. Okay, this is not getting any answer, so I think here dy dx should not be there, and this is option number B is correct. So we have got e to the power y dash equal to x. This differential equation has a solution y equal to x log x minus x plus c. Okay. Okay, next problem. Question number 16. If probability of a equal to 2 by 5 and probability of b equal to 3 by 10 and p of a intersection b is 1 by 5, then p of a condition b into p of b complement condition a complement is equal to what? So the probability is p of a condition b into probability of b complement condition a complement. Okay, this is equal to, I'm writing with another color. So this is equal to P of A intersection B divided by P of B, and this is P of A complement intersection B complement, or B complement intersection A complement, same thing, divided by P of A complement. Okay, so here it is given that P of A equal to 2 by 5. So that means what is P of A complement? This is 1 minus 2 by 5, because total probability is 1. A union A complement, this is equal to total set. So this is 3 by 5. And P of A complement intersection B complement. According to the De Morgan's law, you know that A complement intersection B complement, this is equal to A union B whole complement. So this is equal to P of A union B whole complement. Sorry, here is not complement. This is this. Okay. So that means from here we are getting P of A complement intersection B complement equal to P of A union B whole complement. So that means this is 1 minus P of A complement intersection B complement. This is equal to 1 minus P of A union B, and this is 1 minus, what is P of A minus A union B? P of A plus P of B minus P of A intersection B. Okay, that means 1 minus P of A plus P of minus P of B minus P of B and plus P of A intersection B. So what is P of A? 2 by 5, and this is 3 by 10. 1 plus 1 by 5. P of A intersection B is 1 by 5. This is minus 2 by 5, and this is minus 3 by 10. Okay, this is 3 by 10. This is 3 by 10. Okay, so this is 10 plus 2, 12, and this is 4. 12 minus 4 minus 3. 4 minus is 7, so 5 by 10, this is half. Okay, okay. So that means this is equal to P of A intersection B is 1 by 5, and P of B is 3 by 10. Okay, into P of A intersection A complement intersection B complement, this is equal to 1 by 2, and P of A is 2 by 5. Okay, so this is 2 by 3 into 5 by 4. This is equal to 5 by 6. Okay, so that means which option is correct? This is A option is correct. This is 5 by 6. Okay, okay, next problem. Question number 17, it is saying assume x, y, z, w and p are matrices of order 2 cross n, 3 cross k, 2 cross p and n cross 3 and p cross k respectively. Then the restriction on n, k and p so that py and wy will be defined are. So we have to define p cross p into y plus w into y. So to define p into y we need, so the order of p is p cross k, and order of y is what is the order of y? 3 cross k. So here we need the column of p should be equal to the row of y. That means here k equal to 3. We have got this. Now for w into y we need, what is the Order of W is n cross 3, and Y is again 3 cross K. So here the column and are equal. So this multiplication is already defined. So after multiplying this, the order of the matrix will be n cross K. And after multiplying this P cross Y, P into Y, the order will be P cross K. So to define the addition Py plus Wy, so we are getting Py a order P cross K matrix and Wy is n cross K matrix. So to define the addition, P should be equal to n and K should be equal to K. That means K is equal to K. And we know that already that K equal to 3. From here we are getting K equal to 3. Okay. So the restriction on n, K and P is P equal to n and K equal to 3. That means option number A is correct. K equal to 3 and P equal to n. Next problem. Problem number 18. If this matrix into this equal to 5 by 4, then Y is equal to what? So this is a very easy problem. So this is 1 comma 2 and 2 comma 1 into x y. This is equal to 5 4. This is row and column. So first row is x plus 2y and second row is 2x plus y. This matrix is equal to 5 4. So x plus 2y equal to 5 and 2x plus y equal to 4. Okay. So multiplying these 2 and minus 4y minus, so this is 2x plus 4y equal to 10. So this is y, 3y equal to 6. That implies y equal to 2. So option number C is correct. Y equal to 2. And also x equal to 1 we are getting. Right? Okay. Next problem 19 and 20. And the assertion region based on problems. So which option is correct? Let us find out. The function f from r minus 2n plus 1 into pi by 2, n belongs to z, 2 minus infinity to minus 1 union 1 to infinity is defined by fx equal to sec x. Okay. Is not 1 function in its domain. Reason: the line y equal to 2 meets the graph of the function more than 1 point. Okay. So it is saying the sec x graph. So this is the definition, this is the domain of sec x and this is the range of sec x, and range is whole r except minus 1 to 1. So the graph of sec x is like this, 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 and from here this is 1 and this is minus 1. From here there is no image from minus 1 to 1, and it is saying y equal to 2 meets the graph of the function at more than 1 points. This is 1 and this is 2, y equal to 2 is there, sorry 2. So this function, this line will definitely meet the function more than 1 points. So that means both assertion and reason are correct, and the reason R is the correct explanation of the assertion. So that means A option is correct. Both assertion reason is correct or true, and reason R is the correct explanation of the assertion A. Next problem. Question number 20. Consider the function defined as fx equal to mod x plus mod x plus 1. X belongs to R. Then fx is not a differentiable at x equal to 0 and x equal to 1. Reason: suppose f be defined as and continuous on a open AB and C belongs to AB, then fx is not differentiable at x equal to C if limit this not equal to limit this. So let us first write the fx. This is mod of x and this is mod of x minus 1. So this is plus x and okay, first take x is less than 0. When x less than 0, this is minus x, this is plus x, 1 plus x, 1 plus x. And for x greater than 0 less than 1, this is x because x greater than 0, and this is 1 minus x. So this is also 1, x cancelled, this is also x cancelled. So ultimately we are getting next, what is x greater than 1? This is x minus 1 plus x. So ultimately we are getting 1 when x less than equal to 1 and 2x minus 1 when x greater than 1. So at x equal to 0 there is no problem. It is also continuous and differentiable because the definition break ultimately is at x equal to 1. So the assertion A is wrong and the reason is right, because suppose f is defined to be continuous in the open interval AB and C is between A and B, and for checking the differentiability it is not differentiable when this is the left hand derivative and this is the right hand derivative, these two are unequal, then it is not differentiable. So R is right, that means A is false and R is true, that means option number D is correct. Hope you understand all these problems. If so, please share and subscribe to the channel. I will be back with more videos for CBSE 2025 board examination. Till then, thanks and stay safe.